Hey guys, it's Leverdo1 here, and today we're going to be doing Universe Sandbox 2. Now this is just something different, but we're going to start off by creating our own solar system. Alright, so we're going to get a random known star, and we're just going to put that here. Now, I just want to, just for the sake of it not moving around, I'm going to make it position locked. Just because, and we do that. Alright, now, view, I just like to do this, just because it's, better for viewing stuff. Oh wait, we want the habitable zone to be shown. Where's the habitable zone? Hello? Habitable zone. That's odd. Alright, I'm going to change the mass of this to... because that way it's smaller. There we go. Now we can see the habitable zone. I like a smaller system just because it's, like, I don't know, smaller. Alright, let's put... now we're going to try to get life on a couple of these planets. And we're even going to try to get life on some moons around gas giants. Alright. So let's put one that's definitely not going to be habitable, and then we're going to put these around it. Right now it has 1, 2, 3, 4, 5 planets in the inner solar system, and let's put one in the outer solar system a bit farther, like one here, and one here. Alright, there we go. Now, let's start with this one. Or actually, let's just name this. We're going to name this Lev's Star. Alright, there we go. Now let's go to whatever this planet is named. Ephitzak. Alright, so, what do we know about it so far? Well, it has a good temperature of 31 degrees Celsius, which means liquid water can be on the surface, assuming there's an atmosphere. Let's look at the atmosphere. Oh wow. By the way, this is the mass of the Earth's atmosphere. So, and we've got a good effective temperature. We've got iron core. Now, what we do want is a magnetosphere. So, the Earth's is something like 0.5 Gauss, I'm not sure. That gives it this. On the other hand, it's pretty close to it. What's this? Is this life? There's life on this planet. Wow. That's cool. Alright, let's turn off the... Let's not show the... What am I saying? The magnetosphere. Alright, now, what we do want is water. I have no idea how this civilization formed on a planet with no water. I mean, makes you all wonder, right? Alright, we've got... I want to see water on the surface. Alright, there we go. Oh no, we kind of took out most of these cities. Oh well. It's just cool to look at these. There's a city here. We're gonna call this one Levopolis. Alright. We're gonna call this one Lev's World. I also want to save this. Alright. It'd be really cool if they had like an evolution thing on this. Why isn't there anyone on this continent? There's just a couple cities over here. But motion, its rotational period is way too slow. So we're gonna make it fast. Alright, wonder what the greenhouse effect is. Yeesh, that could get bad, but luckily this ocean might... We have this ocean, so we don't have to worry about that. Because, wow, we've got a 0.9 Earth similarity. Let's see the mass of it. Well, if you look at the mass of it, this could be classified as a super Earth because it has a mass of 1.91 Earths. Alright, so let's move on to the second planet, which is Oratu. Alright, so from what I see so far, I'm going to name it Dusty Rock. Because why not? Alright, so it's got a sucky surface temperature. It's got a nice atmosphere though, so its albedo is fine, so why has it got such a temperature? Alright, so this is definitely a super Earth. It has 2.54 Earth masses. Alright, rotation period, we're going to make that to 1.1 days. Materials, water would be frozen right now, but let's see. Why is the effective temperature so small? That's what I'm trying to figure out. But, as usual, let's get a magnetosphere of, 3 radii. No, hey. There we go. So we got this to protect against solar radiation from that somewhat dim star. And, alright. Let's see. Let's make this higher. But why is the effective temperature like this? Maybe we should give it a higher atmosphere. Alright. Now let's add some water. Actually, I want to see the elevation. There are a bunch of different ways to view this stuff. For example, this shows us that there's going to be a big ocean on the South Pole, obviously. Or I don't know what's north and south. There really isn't any north and south in space. Alright. So, we're going to see a big ocean there. Alright, that looks weird. But let's get it back to default. And materials. We'll increase the amount of water on it. Alright, now it's kind of icy. But, alright, let's... There we go. Now it's wet. Alright, temperature, effective temperature is still that. The greenhouse effect should take care of that. This has got a nice amount of water. Maybe we should check to see the chances of life. That would be under materials. Earth similarity, 0.87. Not quite the last one, but that's still pretty good. Motion. Oh yeah, and let's, because why not, let's give it a moon. The moon might also be, let's put that, something like this. Whoa. This needs to be orbiting the Dusty Rock. Alright, let's add another random moon. Alright. Let's take a look at it, Huh. You don't see many moons with atmospheres. But let's move out to the next planet. Which is over here. And what the heck is that called? Oval Gortask. Alright. Weirdly named planet. Alright, that's what we're going to call it. Alright. Now we need to, first of all, give it a good magnetic field. The albedo is too high. Greenhouse effect is very high. I'm expecting we'll see that go up eventually. Alright, now it's in a... Maybe I should call it Frosty. We're calling it Frosty. Alright. We'll come back to that one. Now, Moltu. Why the heck is it called Moltu? Is it supposed to be like molten? Because it doesn't look molten to me. Alright, the albedo is too high again. The atmosphere is fine, but the greenhouse effect brings it up to 88 degrees. So, but we need to give it a... that would be under materials. We need to give it a magnetosphere. We'll just do 2 radii. There we go. That should protect it from the solar radiation. We'll turn off the view for that. So why is the planet not very similar? Oh, that's why. Alright, let's make it a super Earth. 3 Earths. Now that should bring up the temperature a bit, hopefully. And it makes the greenhouse effect pretty stable. Alright, now where is the water? There's the water. Now sadly it's frozen so far, but I'm sure that'll go up due to the greenhouse effect. Alright. Now, let's do a habitable moon around I'm Anus. What kind of planet is named after your butt? Alright, so let's add a random exoplanet in orbit. That's way too big. No. Alright, random... We'll make first of all, the planet I'm Anus is kind of small. Alright, we're going to make that 18 Earths. And I want it to be completely hydrogen. With a small bit of water. Because why not? Alright. Now I think we're ready to add a random exoplanet. Kepler 228b, how big is that? This is an odd planet. Sorry, you're on. Alright, we're just gonna add a random moon, because that way it will be... Wow, that is very small. What's the size? Moon. We're gonna make it 8 moons. And now, we're going to put it around like this. And then we're going to... Now let's add an atmosphere. But first, we're going to do the magnetosphere. And you've got 2 radii magnetosphere. I might want to make it bigger because of the radiation belt that would come from the gas giant I'm Anus. I'm Anus and Anet. Alright, this is confusing, but alright. Alright, we want an atmosphere. That's what we want. What's the greenhouse effect? The greenhouse effect is 52 degrees. We're gonna shrink that down to like 43 degrees. But let's see. Shouldn't the temperature be going up? Yeah, it's not. Let's see this. Nope, it's going down. That's odd. Alright, let's give it a bigger atmosphere. 8.5. Let's see. Still going down. Let's increase the atmosphere. 18.5. Still going down. Greenhouse effect is 90 degrees. Alright. Let's see. Maybe it'll start going up. Or not. Maybe it just can't contain an atmosphere like this. Alright, well, let's pause this for now and look at it. Maybe we'll make it bigger a bit. 0.84 Earths. That might seriously screw up the planet, but is it gonna keep going down? Yeah, it's gonna keep going down. Alright, the greenhouse effect, we're going to increase this some more. I don't know what's with this planet, but, or actually moon, but let's put some water on it. Alright, there we go. Now, the moon A-net has at least a temporary ocean and some land on it. So, but for some reason, it's still counted as orbiting its star. That's odd. Wait, I want to make sure this doesn't collide with the planet or anything. Trails. Let's show the trail. Alright, let's go back to orbits. Let's make sure it doesn't collide with the planet. Actually, it looks like it's going to collide with the planet. Actually, maybe not. Is it going to? Nope, looks like it's fine. Alright, let's move on to the next planet. Moon. Alright, let's go to 90. Alright, we're going to make that a very large. We're going to make it 0.76 Jupiters. And then small iron core. Alright, we've got that. Now let's add a random exoplanet in orbit. No. How big is that? Let's take a look at it. No. Alright, we're going to rename this to something that Universe Sandbox would give us. Let's increase the water on it. This music is getting way too loud. Is it just me, or is that music getting way too loud? Alright, there we go. Now, we need an atmosphere of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Now I need plus 18. Which gives it a greenhouse effect of 27 degrees. And let's do Earth similarity is 0.1. Alright, the size Earth, we're going to make it slightly larger, 6 Earths. Now we need to do the materials. Alright, that's fine. I think so. What's the rotation? I'm gonna do that. Now it's a bit more like Earth, but there actually is a slim chance of life evolving right now, but not that big. Nope, it's still snow right now. And voila, magic. Alright. Now, we're going to look at this last world. We're going to make it actually very big. It's going to be 2.5 times Jupiter. Materials. Why is there so much of this other stuff? Hydrogen. Voila! A massive planet. It'd be cool if we actually made it like another star, but... Materials. No, I don't think we want that planet. What we're going to do is we're going to speed up things and check out the planets later on. Actually, let's just look at this planet. Yeah, well, I think this one's a lost cause, but let's try this anyway. I'm just going to do 0. Actually, that mass is fine. A bit small, but we can make the effective temperature like this. Alright, but we're going to need a very big magnetosphere. I'm going to do 1.6 Gauss. Alright, that gives it a pretty big... Whoa, what's happening? Oh, there we go. Alright, now, if we compare that... But look how big the star is from this distance. But the effective temperature is perfect for life. Perfect. Alright, we want more of this stuff. Now let's add some water, which is actually going to, I think... My guess is that it's going to, like, there's no atmosphere yet, so we need to put that. Is it just me, or is that the same texture as the other one? Is that farther out planet? Or moon? Alright, so, let's give it an atmosphere. Atmosphere mass... Doesn't need that big of an atmosphere. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Alright, there we go. 3.1 E plus 18. Now we have an atmosphere for this one. And I want to see how Lev's world is doing. Yes, we've got flourishing cities. Still, they haven't... Start exploring, you morons. You've only covered like a tiny bit of the planet. Alright, but I want to take a screenshot. So, we're going to turn off the habitable zone. And now let's take a screenshot. Alright, cool. We got a screenshot. And now we're going to just speed things up and see if these planets survive. Alright, let's speed that up a bit more, and let's look. Alright, let's look at Opid. The Opid seems fine. But let's just check materials. Is it losing water? No, I don't think so. Yeah, I think that one's fine. The temperature is 102 degrees Celsius. We need to make that lower. Nope. Higher. Alright. Let's get it to a balance. Alright, when it balances, that's when we'll know it's good. Alright, the temperature is going down rapidly, but the effective temperature is staying relatively the same, so. Alright, well, I think we're good on this one. Might be quite hot, humid. Now let's check out Lev's world again. Do morons start exploring? Where'd they go? Are they dead? Mommy, my civilization is dead. What happened? Huh, something happened to make it... Oh, the surface temperature went up. Let's make it that lower. Alright, we've got this. Alright. Hopefully this will get it down to a temperature. Let's get it down super quick. Alright, I think that's down to a temperature we like. Actually, the effective temperature is kind of low. Oh no, the temperature is going back up. We don't want that. Alright, well, let's just hope for the best with this planet. Let's pause and see if... Let's see if the dudes came back. Dudes? Did you come back? No, they're dead. A shame. Alright, let's see. Earth similar. Alright, let's put the temperature at 21 degrees. I don't like... Alright, let's try increasing the albedo. Alright. Temperature is going down for sure. Alright. Well, that's too bad about the dead guys. But let's leave and check out the next world. Dusty Rock, how are you doing? Alright, so doesn't seem to be anything on the Dusty Rock world. I don't think we have any organics. That might be a problem. Alright, the mass is 2.54 Earths. Radius, surface temperature. Let's see if how the surface temperature is going. Oh, I'm not sure about that. Not quite sure I really like that pattern. At least if it's going up, at least it's going slowly. It's got a nice moon around here, which I don't think is really of any use, but let's check out Frosty. Frosty looks like a nice planet. The temperature is 17.4 degrees Celsius. Why don't they have a freaking Fahrenheit on this? Fahrenheit. Alright. Frosty seems fine. Let's go look at Molto. Molto is not alright. Temperature 21. Greenhouse effect might be. Let's look at this. Surface temperature. And that goes down quickly. Alright, let's give it a way bigger atmosphere. let's give it an albedo. Best thing that happened is I wish there was like a button to maintain a stable temperature. Oh well, Molto is a bit too far out to really sustain life anyway. So, let's check out the moon planets. Which I think is around Imanus. I'm Anus, and then there's Anus and sadly, did not last. Let's look at the temperature. Oh, no wonder. Let's give it a bigger atmosphere. Ooh yeah! Alright, it's sort of slowing down as... Alright, and water. Voila! Maybe we should give it an albedo. I don't like how fast it's warming up. That's not good. Alright. Maybe what we need is a balance. Let's do that, but let's also make this higher. Huh. You if you give it an albedo of that, then I have no clue what happened. Why does the temperature fall so fast? But not if you do that. Huh. Well, maybe we want to do that with other planets. Whoa! I said whoa. Alright, there we go. Now let's... Alright, first of all, I want orbits. Let's look at needy. Is it a needy... Is the... Somehow it appears to have maintained its atmosphere and temperature. Let's see a graph of this. Or that's not good. There we go. Huh. It's very, very, very odd. Greenhouse effect is incredibly small. We need a higher greenhouse effect. Or even higher. There we go. Let's give it 19E. 11.9E. Alright, let's see if the temperature is... Nope, but it's still falling. Alright, that should last some time. Alright, and now let's check out that outer planet. Oh, right, I deleted it. Let's look at the inner planets one more time. Alright, Opid. Life? No life. I didn't choose the thug life. The thug life didn't choose me. Alright, Lev's world. How are things on Lev's world? Well, the temperature seems fine for life. You know, if they need a better sign of life than the shiny lights that show a city would be to have green stuff. Hey, but I have an idea. Let's put another Lev's world in. User objects. Loves world. I saved all the worlds that I thought I got really close to having life on. Alright, let's put Lev's World 2 there. Is there life? No life. Oh wait, life. Yay! We got to life. Alright, however, let's make sure the temperature doesn't get out of hand. See? Oh no, that's not good. How is that? What? Why? Alright, we need a... That was not good. We need a higher atmosphere. Huh, that was odd. Surface temperature is 280. I do not understand this. Alright, let's give it back to 18. Alright. Well, I think that concludes today's first episode of Universe Sandbox. I don't know why it's like that. Alright. Well, see you guys next time on Universe Sandbox.